Hey, this is Bill, and we're going to program something stupid. Today, I'm just going to show you a very simple introductory program on the G15. We're going to add two numbers together. We're not even going to print out the result. We're just going to look at it in the emulator. So let's jump right into our development environment where I've got my assembler set up. I've also got the emulator up and running and ready to go, and we're going to start working on our program. I'm going to start out just with a comment to remind us what all the fields are. Let's see, p dot t for the time at which this command runs, the next instruction address, the characteristic, the source line, the destination line. This is going to be whether or not it's a breakpoint, and we've got room for a comment. All right, so that's what each line of code is going to look like. Obviously, the comment is just a comment. It means nothing to the G15 or the assembler. The rest is the actual code we're writing. So we're going to start this off at location 0. This one is a little interesting to start with. I'll type it up, then explain it. U01, 02, 0119, 00. So this is an immediate instruction. That's what this U here means. An immediate instruction starts executing at the very next time and continues executing until we reach this T. So this instruction is going to start executing at time 01, the next time after location 0, and it's going to continue executing until the time reaches 01 again. So it's going to execute all the way around the drum for one full rotation. What's it going to do? It's going to copy the contents of line 19 to line 0. So this will copy the entire contents of line 19 to line 0. So I'll just put our comment there, copy program from line 19 to line 0. All right, and I've got that. Let's not worry about location 1 for a second. We'll just jump up to location 2. This will be the first instruction in our program. At this point, this is sort of weird. We're not executing from line 0. We're executing on line 23. So we need to do an unconditional branch to line 0. We're going to tell it go to time 3 and 2131. This is just kind of telling us go to 003. That's it's actually using the instruction, the return instruction, but it ignores the mark and just goes straight to position 3. So that's essentially change execution, go to line 0, time 0. Cool, okay. So this is kind of boilerplate, something you might do at the very beginning of any program. Copy it to line 0, then go to line 0. You'll find a lot of programmers that I've seen will also put this in position 1. If the test flip-flop is set, you can end up going to line 1 instead of line 0 when you try to jump to line 0 and start your program. So this catches that and does the exact same thing, copying from 2 to 2, so once again all the way around the drum, and then going to the instruction at position 2. Now that we've hit that, we'll actually start the meat of our program at position 3. At position 3, we're going to say wait until time 4, then go to time 5, but at time 4 we're going to copy from line 0 to line 28, or in other words, let's write we're transferring the value on line 0, position 0 into the accumulator, and the 28 name for the accumulator means we're clearing the value. What value are we going to load? Let's just put in let's do 2 plus 3. That'll be fun. So we're going to load 2 into the accumulator and then go to 5. at location 5, we're going to wait until time 6, then go to instruction 7, so we're copying the value at 0, 0, position 6 into the accumulator, but the plus accumulator. In other words, when you write to line 28, you are writing to the accumulator and clearing the old value, so you're basically replacing the previous value. When you write to line 29, you're adding to the accumulator. What value are we going to load? Well, it's the value at time 06. Let's do plus 3. So 2 plus 3 equals 5. That sounds good to me. Then at time 7, we're going to halt. All right, what's this instruction mean? 1631 will halt. The time, if you read the instructions for the halt instruction, just says it has to be L2, in other words, 2 greater than the location, so 7 plus 2 is 9. Now, even the halt instruction has a next field. Once the machine halts, if we start it again, it will progress to whatever address you've got in the halt instruction's next field. In other words, it will run this program a second time. So that's our whole program right there. Let us assemble it. Let's save it first. We got all zeros there. Okay, if we run that again, here's our nice short little program. It doesn't even have a number track, which means this isn't a bootable tape. Let's throw a number track on there. Now you can see it's got a number track on the tape and then our program. If you were doing this for real, you might not want to waste the paper, but this is all virtual, so that's fine. We'll output that to simpleadd.pti, and we're ready to go check out the emulator. Here we are over at the emulator. I'm going to unload the current tape, and I'm going to load that simpleadd.pti right there, simpleadd.pti. Going to reset the machine, and we'll watch what happens. Loads 2 blocks. And if you look over here, line 0 is still empty. It's all full of zeros. But if we check out line 19, we see there's a bunch of stuff. Some of this is left over from loading the number track, but the first handful of words here are our program. Yeah, we can select those right there. We also see a copy of those first 4 words down in line 23, which is actually going to be our initial command line. So when our program starts executing, it can only be 4 words long. This first word is that copy from line 19 to line 0. The second word is that extra copy from line 19 to line 0 in case the test bit is set. This third word is our unconditional jump to line 0, word 0. And then finally, this fourth word is the first real word of our program. It's not going to get executed from line 23 because after this third word, we'll be executing our instructions from line 0. So I'm going to go ahead and set the compute switch to go. And just that quick, what's happened? We've got the number 5 up in the accumulator. We are at command number 7, location 7. That was our halt command. And the machine is halted. So just that quickly, it's added 2 and 3 to get 5. If we stop the machine and run it again, well, we'll see a quick little flicker. It goes by too fast to see, and we're right back there. We can stop the machine and single step it with this step button down here. We see we're at location 3. We've loaded 2 into the accumulator. If I step it, we're at location 5. We've added that 3 to the accumulator, and we've got 3. And if I step it again, we're at location 7, and we've halted. So there's our firstest and stupidest Bendix G15 program, adding 2 numbers, adding 2 and 3 to get 5. Hope you've had fun.